Guys, in this video we will discuss about that how to solve the simultaneous differential equation with constant coefficient. So first of all, to solve the simultaneous differential equation with constant coefficient, here I will consider the total n number of simultaneous differential equation with constant coefficient, and we can write it like this, that dx1 dt is equal to a11 x1 plus a12 x2 plus dot dot plus a1 and xn. dx2 dt is equal to a21 x1 plus a22 x2 plus dot dot plus a2 and xn. dx3 dt is equal to a31 x1 plus a32 x2 plus dot dot plus a3 and xn, and if we consider so on, we at last we will get dxn dt is equal to an1 x1 plus a into x2 plus a in xn. We can solve this simultaneous differential equation with constant coefficient by various methods, but here we will discuss about only the here our main objective is to find the x1, x2, x3 and xn, and here we will try to find the value of x1, x2 and xn by using the elimination method and differentiation method. And here I will solve two problems on the differentiation method. So now let us see that how can we solve the problems or the simultaneous differential equation with constant coefficient by differentiation method. So see here we consider two equations, dx dt is equal to 4x minus 2y and dy dt is equal to x plus y. So to solve or to find the value of x and y, we will try here, we will write that dx dt is equal to 4x minus 2y and dy dt is equal to x plus y, and just name as 1 and 2. And now here I will differentiate 1. So if we differentiate 1, what we get? That d2x dt2 is equal to 4 dx dt minus 2 dy dt. And see that 4 dx dt, and if we use the value of dy dt from 2, so we can write that 4 dx dt minus 2 into x plus y. And so from here what do we get? That 4 dx dt minus 2x, and this is equal to minus 2y, whereas we can use that 2 minus 2y is equal to that from 1 we can use that the minus 2y is equal to dx dt minus 4x. So see here, then minus 2x minus 2y, and here we use the value of minus 2y, that is the dx dt minus 4x, and we put here the value. So from here we can get that the equation like this, d2x dt2 minus 5 dx dt plus 6x is equal to 0. So now we have to solve it. See here, this is a homogeneous equation of x, and we can easily solve it. If we take that x is equal to a e to the power amt with the trial solution, then the auxiliary equation will be m square minus 5m plus 6 is equal to 0, and then from here we can get the general solution is x is equal to a e to the power 3t plus b e to the power 2t, which here a and b are arbitrary constant. So we get the value of x. Now our objective is to find that how can we find the value of y. So we can find the value of y by using 1 and 2. See here, if we put the value of x here in 1, then we have to differentiate, and if we put the value of x in 2, we have to integrate. So now here I will use to find the value of y by using 2. So now let us see that how can we solve it. That is, we get dy dt is equal to x plus y, and we get x is equal to a e to the power 3t plus b e to the power 2t. So now if we put the value of x in 2, so then what we get? I will just show you here that from 2 we can write dy dt is equal to x plus y, and from here we can write dy dt is equal to minus dy dt minus y is equal to x. Now we put here the value of x, and now see that this is a linear differential equation. So where integrating factor we can find it by e to the power minus integration minus dt, that is e to the power minus dt. And so we can write the d of y e to the power minus t is equal to a e to the power 2t plus b e to the power t dt. And if we integrate, we will get y e to the power minus t is equal to b e to the power t plus half a e to the power 2t plus c. And from here we will get y is equal to b e to the power 2t plus half a e to the power 3t plus c. Whereas, so now we can find the value of x and y simultaneously. These are the solution where a, b, c are arbitrary, where a, b, c are arbitrary constants. So now I am going to show you another one problem. See that here we will get the differential equation is the homogeneous differential equation. So now the question is that if the differential equation is non-homogeneous by after differentiation, then how can we solve it? So let us see to solve the problem. So now here I will just show you. See here that here I consider this two equation like this, that dx dt is equal to y plus e to the power t and dy dt is equal to minus x plus 1. So here we will just give it dx dt is equal to y plus e to the power t, this is 1, and dy dt is equal to minus x plus 1, we will give it number 2. So now if we differentiate 1, what we get? d2x dt2 is equal to dy dt plus e to the power t, and what is the value of dy dt from 2? That is minus x plus 1 plus e to the power t. So, and if we rearrange it, we will get d2x dt2 plus x is equal to 1 plus e to the power t. This is a non-homogeneous equation. So here we have to also find the particular integral. See here that d2x dt2, and from here if we take that x is equal to a e to the power m to be the trial solution, then auxiliary equation is m square plus 1, or m is equal to plus minus I. So roots are purely imaginary. So x complementary function cf x is equal to a cos t plus b sin t. And here now we have to find, since the right hand side is not equal to 0, so here we have to find also the particular integral of x. So how can we find the pi? That is pi is equal to 1 by d square plus 1 plus e to the power t, and here we use the distributive law, that is 1 by 1 plus d square of 1 plus 1 by d square plus 1 e to the power t. And here to solve it, here we will use this formula 1 plus x whole inverse is equal to 1 minus x plus x square, and here x stands for d square and d square stands for dt2. So here 1 plus d square whole inverse, and so here we will get 1 minus d square plus d4 plus of 1, and 1 by d square plus 1 e to the power t, as we know that 1 by f of d e to the power mx, and here f of m not equal to 0. So here we will put, and here m is equal to 1 and f of d is equal to f of m, that is f of 1 is equal to 2. So we will get half e to the power t, and if we simplify, we will get 1 plus half e to the power t. So we get x is equal to a cos t plus b sin t plus 1 plus half e to the power t. And now the question is that how can we find the value of y? So if we use the one that y is equal to dx dt minus e to the power t. So here if we put here the value of x, that is d dt of a cos t plus b sin t plus 1 plus half e to the power t minus e to the power t. And after simplification, we will get y is equal to b cos t minus a sin t minus half e to the power t. So this is the value of y and this is the value of x. So I hope you will understand that how to solve the simultaneous differential equation when this equation is homogeneous by after differentiation, and when the differential equation is non-homogeneous. So thank you for watching.